Morning, everybody. Or afternoon, I guess, if you sleep in and you're just now watching this. Notes for today, rule number 1 is everybody right now take a super deep breath. Okay, don't panic. Problems are gonna look kind of weird today to start with. I promise I'm not throwing anything major at you. You just need to take a minute to take a deep breath and realize that these are actually, even though they're gonna look harder, less work than what we've been doing. Okay, so today we're gonna talk about solving literal equations. Okay, and literal equations are talking about solving a formula or something that's made up of all letters and rearranging those variables to be solved for something else. Okay, I know, right? My students don't like that. So as soon as I write this down, so let's say we have something like A plus B equals C. Currently, right now, this is set equal to C, so it's solved for C. But what happens if instead we want to solve this for B? So this arrow pointing to B is telling me to solve this for B. Okay, that means we want to get B by itself. And my students are like, what the heck? There's no numbers for me to move. That's where this is actually easier. Okay, you're gonna do the exact same process that you've been doing solving equations. It's just that you're gonna be rearranging letters. So if I were to say something like 4 plus B equals 9, you would all agree with me that we want to undo a positive 4 by subtracting 4, right? And we'd subtract 4 from each side. So we want to apply that same idea over here, right? 4 and A are in the same situation. They're attached. A and B are attached with addition and subtraction, right? So I'm looking in front of the A. The A is positive. I'm going to move it with a negative. And whatever I do to one side of the equal sign, I also have to do to the other. Now, just like over here, right, those 4s would cancel out. Those A's are going to cancel out, which is going to leave us with a B on the left-hand side. Okay, on the right-hand side, my students, this is where they don't like it because this is actually less work. We would have to do the math of 9 minus 4, but C minus A we can't do anything with. Those aren't like terms. So we just leave it as C minus A, right? And when we're here, B is by itself, we now have B equal to C minus A. Okay, so this is the same process we want to use all the way throughout. We're just using inverse operations to move letters around. So let's say we have something like W over Z equals Y, and we want to solve this for W. Okay, so if we want to solve this for W, right, this is division. And we undo division with multiplication. So we're gonna multiply each side by Z. Again, those cancel out, which leaves us with a W on the left. I can't do anything with Y times Z other than just leave it as Y times Z. Now, whether you write the parentheses for multiplication or write a dot, all of those are fine as long as you recognize that two letters sitting by next to each other without an operation is in fact multiplication. And that's just our answer. W equals Y times Z. W is by itself. We are done. Now, obviously, there can be more steps to these. They're not always just one step. So what if we have AB plus C equals D? And let's say we want to solve this for B. Okay, so if we want to solve this for B, just like with any equation, right, order of operations backwards, so we have to undo any addition and subtraction first. So if I had something that said 4B plus 7 equals 12, right, I would move that 7 first. So the C and the 7 are in the same position, so that C is what I'm going to move first. So I'm going to undo adding C by subtracting C. So those C's are going to cancel, which will leave me with an AB. Again, I can't do anything with D minus C. It's just D minus C. Now, I'm not done because B is not by itself. So to get B by itself, I'm going to need to move the A, right? When we don't see an operation at all, that's really multiplication. And we undo multiplication with division. Now, remember, we said multiplication and division are a property that go throughout the entire problem. So if I'm going to divide by a, I need to divide this entire side by a. So make sure that fraction bar is including all of it. Here's the piece where we need to make sure we actually have understanding of what's going on. Because it is totally fine for you to say that your answer, sorry guys, it's windy with my air conditioning blowing. It's totally fine to leave your answer as b equals d minus c over a. The problem is that if this were free response, you're fine, but if it's multiple choice, you might not have the luxury to writing it however you want to write it, and you'll have to write it or select it in the format that's equivalent. Which means we need to understand that this has some other options that mean the same thing. For example, we said division means it's happening throughout the entire thing. So dividing the whole entire thing by a is the same thing as dividing each individual piece by a. Those individual pieces are called terms. So b equaling d over a minus c over a would be equivalent. That would be the same representation. Maybe the order is changed, right? We should know that d minus c is the same thing as a negative c plus d. And so it would be fine if we said b equals negative c plus d over a. Okay, that's going back to knowing your rules of what works in addition and what works in multiplication. Okay, that's not an issue with you understanding how to solve. You'll only run into this issue if it's multiple choice. Free response, as long as you have the variable by yourself, it's fine. Multiple choice, you'll have to find something that's equivalent. Okay, something that means or represents the exact same value. Now, sometimes we can take these problems, and actually the majority of the time, we'll actually see letters and numbers together. Okay, and let's say we want to solve this for y. Okay, so again, if we want to solve this for y, our goal is to get y by itself. So the first thing we're going to do is ask ourselves, right, order of operations backwards. If I'm getting y by itself, I want to undo any addition and subtraction. So is there any addition or subtraction happening over here? Yes, right? So I want to move this positive 8x. Okay, and I'll move a positive 8x by subtracting 8x. But again, you don't really need to completely overthink this. Okay, 16 minus 8x, I can't combine those. They are not like terms. The only trick that I'm going to tell you is that remember that beloved formula from middle school of y equals mx plus b? The majority of the time, the thing that has the x with it is going to go first. So in terms of finding that equivalent representation, you're almost always going to see that negative 8x first, followed by the positive 16. Now, you wouldn't be wrong if you wrote 16 minus 8x. You're just going to see it in this format the majority of the time, so it's a good habit to get into. Okay, again, then we will undo multiplication with division, and remember, division goes all the way through. So we could just divide this entire right-hand side by 2. But again, okay, in terms of how things are written most of the time, right, dividing this whole entire thing is the same thing as dividing each piece. And that's more likely what we're going to see because these numbers can be reduced. So negative 8 divided by 2 is negative 4, and 16 divided by 2 is 8. And so this is the likelihood what we would see as a multiple choice answer, and it's also great because it's in a nice simplified form. Y equals negative 4x plus 8. How about 5x minus 1/2 y equals 19? Okay, and let's solve this for y. So if I'm going to solve this for y, I'm going to move my x first because it's with addition and subtraction. So I'm going to move a positive 5x by subtracting 5x. Again, just because I normally write my x first, I'm going to put a negative 5x and a positive 19. Now remember that sign stays with the 1/2. So over here I have a negative 1/2 y. Okay, then I'm gonna undo that multiplication with division. So I'm gonna divide by negative 1/2. You could choose to multiply by the reciprocal, that's fine, as long as you realize multiplication and division are happening to every single term, every single piece. So negative 5 divided by negative 1/2, two negatives make a positive. 5 divided by 1/2 gives us 10. Remember, when we're dividing by 1/2, it's the same thing as multiplying by the reciprocal of 2. Okay, then we're gonna do 19 divided by 1/2. A positive and a negative make a negative, and that gives us 38. You won't always get nice, neat numbers. So sometimes you'll be asked to solve and you'll just get wonky fractions, and that's okay. So if you're asked to solve 3y equals 5x plus 11, and you divide by 3, we might just end up with y equals 5/3 x plus 11/3. That's okay. Fractions are our friends. Just make sure you're getting them reduced where you can. Okay, last one. 4 times x minus 7 equals 8y plus 2. And let's solve this one for x. Okay, so if we want to solve for x, first things first, we need to get it out of these parentheses. So there's a couple choices here. You could distribute, you could move that 4, whatever. So I'm going to go ahead and distribute and say 4x minus 28 equals 8y plus 2. Now to get x by itself, I need to undo addition and subtraction. So I'm going to move this 28. 28 is a like term to that 2. So those are terms I can actually put together. So I'll say 28 plus 2 is 30. Then I'm going to undo multiplication with division. Again, I'm dividing in all 3 places. 8 divided by 4 is 2. 30 divided by 4 doesn't go evenly, so 15 over 2. If you changed it into a decimal or a mixed number, that would be fine as well. So make sure you're watching the multiple choice options in your homework and picking the option that represents this the best.